Hi guys, hope all of us are doing great. My name is Ernest and this is Ernest Sciences and Mathematics TV channel. In my channel, I deal with the different aspects of mathematics, physics, chemistry and biology. And today we are going to look at a topic in mathematics that basically deals with the concept of coordinate systems. Now in our earlier video, we had looked at the concept of one of the coordinate systems. And we said that we are going to deal basically with various sets of these specific systems, whereby we had said that we first added the Cartesian coordinate system that sometimes we're going to find in some of our literature are being referred to as the rectangular coordinate system. And then we're going to look at the cylindrical coordinate system, and then lastly we shall look at the concept of the spherical coordinate system. Now these are going to assist us in trying to define some of the concepts we are going to encounter in physics, and especially for today, as we are going to look at the concept of this cylindrical coordinate system, we're going to see a relationship that is going to be perhaps mentioned in one of the areas, of course, of these specific services that we are going to use in defining the concept of the spherical coordinate system. So basically, the spherical coordinate system is one of the, or rather, some three-dimensional version of the polar coordinate system. And we're also going to look at how this one is going to, of course, establish that kind of a relationship that I'm going to mention. So in this specific case, just like the first one that we had dealt with for the rectangular coordinate system, we're going to use some specific services in order to define this type of coordinate system. So therefore, these services are going to consist of two planes, where basically the first one is going to be a plane that is going to consist of the Z plane, which basically I'm going to illustrate. And this is going to be a plane that is going to be parallel to the XY plane that I'm just roughly illustrating. And then we are going to look at a half plane. And this half plane is basically going to be a plane that is going to be formed, and it's going to be a plane that is going to be parallel to the Z axis, and it's going to form an angle with the Z X axis, as we're going to see also in our illustration. So basically this is going the three parts which are going to be used in trying to define this specific set of what we refer to as the cylindrical coordinate system. So there's also going to be a cylinder that's going to be involved in this particular case, who's going to form what we refer to as an axis with the Z axis in this specific case. So to make this one comprehensive, therefore I'm going to use some three illustrations on the board which are going to assist us. And of course, just like in the coordinate system, we're going to include the aspect of branches for these various sets of the services that are going to assist us, of course, in defining this type of the coordinate system, as I've said. So basically, the illustration that I've given on the board consists of three sets of A, B, and C. And this is a set of services which are going to define what we refer to as a cylindrical coordinate system. As in our first case, where we talked about the concept of the Cartesian coordinate system, that we basically refer to a point as an interaction between the three planes. For this case, we're going to have a cylinder, a half plane, and then the Z plane, which is a constant interacting to form this what we call the cylindrical coordinate system. We're going to find out that this specific set is going to form for the first case, the cylinder is going to form a radius that is going to form an axis with the Z axis. So therefore, the range, the distance between the Z axis and the point on the cylinder is going to form a radius that is going to be constant. And we have seen that for the second case, for B, this half plane is going to be, of course, parallel to the Z axis, but it's going to form a specific angle with the ZX plane, which we have referred to as phi. So this phi is going also to be a constant angle. And then we're going to see that for the last case, we have got a third service that is going to coordinate with the two to form a cylindrical coordinate system. And that is going to be the constant Z plane, which we are going to refer to as Z. And of course, it's going to also to be constant. So in this three specific scenario, we're going to see that there's a specific range that we can be able to assign for the first, second, and third one, just as in that case, so that we can be able to create boundaries as we have done for the first case of the rectangular coordinate system. So in our first case, we're going to have this specific cylinder that is going to have a variable for r, and the range of r is going to vary between 0 to positive infinity. So it's going to be a positive value in that specific case, and that is going to form our first range for this set of a service. And the second one is going to be phi, and phi is going to range between 0 and what we refer to as 2 pi. So as we're going to realize later in this specific discussion for the cylindrical coordinate system, we're going to use angular extension in terms of radians. So that's why I've indicated this one as 2 pi. And for the last one, for the z plane, this is going to be ranging between what we call negative infinity to positive infinity, just as illustrated as such. So take note of these equality signs as we are going to, of course, mention them at some point in our discussion. So in this case, we're going to see that the point that is going to be perhaps indicated on this cylindrical coordinate system, we're going to use the initial for P for point, and that is going to be with reference with the origin that I've just indicated at this specific point as O in this particular case. So I hope that this is going to be elaborate for us. And just for a quick recap, I've stated that for the cylindrical coordinate system, we're going to have 3 services which are going to assist us define this specific system. And these are going to be a cylinder that is going to form a radius r with the z-axis, and of course, as I've illustrated in the first case, for the 3-dimension of x, y, and z. And then secondly, we're going to have a half plane, and this plane is going to be perpendicular to the xy plane, but it's going to form parallel, of course, to the z axis as I've mentioned. And this particular plane for zx is going to form an angle phi at this specific point with this half plane. And then lastly, we're going to have the z plane, which is going to be a constant, of course, and going to be parallel to x y plane as I've illustrated on the board. Now, there's this specific angle that I've referred to as phi. In our discussion on the quantum numbers in determination of orbital angular momentum, we had talked about the concept of phi, and sometimes we refer to this one as azimuthal angle. I hope my pronunciation is okay. It's referred to as azimuthal angle, and this is an angle that was defined by Arnold Sommerfeld, and it's going to refer to the, of course, an aspect of atomic spectra that we had talked about in our quantum discussion, quantum mechanics discussion. So we're going to reserve that one for that specific discussion, but of course I felt it's necessary for us to mention it so that we can be creating a link between these discussions that we have for various topics. So I'm going to have a last illustration that is going to show the interaction between these 3 services, which are of course going to assist us define a point in the cylindrical coordinate system and other ways in which we can be able to, of course, define a surface, a point, or a volume in a cylindrical coordinate system. So in this specific set of 2 illustrations, I've given this one for A and B, and we're going to look at this in this in a way that we are going to relate A with B respectively. So this is going to form a final set of the interaction between these 3 services in the form and the formation of this cylindrical coordinate system that I've been talking about. So in this case, we have had a discussion in our previous illustration where I said that we are going to define this specific set of points using the 3 services. And the first one I said is for r, which is going to give a radius that is going to be constant, of course. And this is going to be the extension from the axis, the z-axis, to a point on the surface of a cylinder, which was our first surface. So it's going to form a radius of r at this specific point to this point P that I've mentioned. So it's going to form a first element in this particular set of a point that we have referred to as P. So the next one is the extension of our xz plane from this specific point along the x-axis, then therefore it's going to form an angle phi, half angle phi, this specific point, as we have said. So it's going to be ranging between 0 to 360 degrees, or to 2 pi, as we have said, in terms of radians. So therefore it's going to be also a second part of what we're going to use in describing the rectangular coordinate, the cylindrical coordinate system. And lastly, we talked about the concept of a z plane, of course, which is going to be used in this case. So to quickly define these 3 points, or illustrate them, I've said about the angle phi. So it's going to extend from this zx plane to this specific point along this specific trajectory, of course, and this is going to form an angle phi. And then the next, we're going to have a half plane that is going to be illustrated using this specific point. So the interaction between this distance and this one is going to form a point of interjection at this specific point that I've indicated for P. And the interaction between that point P and the Z constant that is going to be given us in terms of this plane that is parallel to xy is going to form a point P that I've illustrated at this specific point. So that's the way in which you can be able to visualize this specific set of what we refer to as the cylindrical coordinate system. And this is, of course, in conjunction with the first one that we had given of the rectangular coordinate system, are going to assist us in trying to solve some of the problems that we may encounter insofar as coordinate systems are concerned. And this, of course, as we said, a coordinate system is going to form a point of reference for us in trying to define some vectors. Now that we said that vectors have got quantities and, of course, magnitude, or rather magnitude and direction. So in this case, of course, I hope that this is going to be of essence, of importance for us, and it's going to, of course, assist us try to define some of other concepts that we may come across in physics and mathematics. So that is it for now, guys. Bye. Catch us in our next video on the discussion on spherical coordinate systems. God bless you.